Hi everyone, this is Srividya, Assistant Professor in the Department of CSIT. In the last session, we have seen structures, declaration, initialization, and accessing of structures. And apart from that, we have seen nested array of structures, and pointers to structures. So in this session, I am going to discuss nested structures and self-referential structures in C. So what is a nested structure? In C, a structure within structure is called the nested structure. One structure can be declared inside another structure. In the same way, structure members are declared inside a structure. So the syntax of this structure is struct name 1, members, member 1, member 2 and member n, struct name 2, member 1, member 2, so on, member 1. Like I said, we need variables to access the members of the structures. So without variables, what it is, it's just a template or it's just a normal declaration, but memory will not be allocated for structure without the variable. So we need structure variables to access the members of the structure. Suppose int roll number, struct student, char name of 50. So this is your structure members. Again, immediately you will start the inner structure. Struct, let's consider student 1. Okay, int date of birth, float, marks. So here, this is inner structure. Inner structure gets closed here. I'm considering it as V2, variable 2. And this is the outer structure. This is V1. So this represents your inner structure data or members of the inner structure. And this is your outer structure. So now, how we will access the members of the inner structure as well as the outer structure? While accessing, if you want to access the members of the structure, we need the dot operator. With the help of dot operator, you will access the members of the structure. So if I want to access the members of the outer structure, suppose this one, this is my outer structure. If I want to access the members of the outer structures, it will be v1 dot roll number, v1 dot name, and that's it. There are two members in the structure. So there are two members only in the outer structure, and the variable we have taken as v1. So it's v1 dot roll number, v1 dot name. Suppose if I want to access the members of the inner structure, how the members of the inner structure were accessed? It is outer structure variable with inner structure variable with the members. It's inner structure. v1 dot v2 dot dob, date of birth, v1 dot v2 dot marks. Like this, the members of the inner structure will be accessed. Okay, the outer structure members will be accessed directly through its variables. It is v1 dot roll number, v1 dot name. But the members of the inner structures are accessed like v1 dot, v2 dot, date of birth. So let's see one more example. Struct class int p, int r. So what are these? These are the members of the outer structure. Next, struct class 1. So you will not end here, like you can't give a closing brace here because this is inner structure I am writing here. Struct class 1 int K int P. Okay, this is your inner structure now. And we will take one variable like V1. Again, V1, and this inner structure gets closed here. And this is your outer structure V2, that is closed here. So now if you want to access the members of the inner structure, so this is inner structure, and this is your outer structure. If you want to access the members of the inner structure, so now how to access the members of the structure? This V2 is a variable that represents the outer structure. V1 is a variable that represents the inner structure members. So it is V2 dot V1 dot K. So if you want to access the members of the inner structure, you have to use both the variables, outer variable, inner variable, and structure member. Okay, if you want to access the members of the structure, you have to use outer variable, outer member variable, outer structure variable, inner structure variable, and inner structure member. It is V2 dot V1 dot K. Okay, V2 dot V1 dot P. If you want to access the outer structure members, what is the outer structure member? It's V2. It's V2. V2 dot P and V2 dot K. Like that you can access the members of the nested structures. So this is the sample program. Here we have taken the employee data again. So employee data consists of address, the struct keyword, address was given. So the members of the structures are city, PIN and phone number are considered as the members of the structure. So what are the members of structure here? City, PIN number, PIN code and phone number of a particular employee. So this is your outer structure. Next, what is inner structure consists of? Struct employee, name, address. Struct address add as taken. You can declare like this also. Okay, so void main, struct employee EMP. The name of this one is employee EMP, employee details. So here we are entering the name, city and PIN code. So how you will read? Because it is taken as EMP as a variable. EMP is a variable. So now if you want to access the members of the structure, it is EMP dot name and EMP dot add dot city and EMP dot add dot PIN, EMP dot add dot phone number. So these are the inner structure members. This is an inner structure member. Sorry, this is an outer structure member. These are the outer structure members. And again PIN code we have printed, name, city and phone number. Simple, we have to take the two variables. If you want to access the inner structure, you can use the outer variable and inner variable, and with the dot operator, you can access the members of the structure. And before accessing, sometimes if you want to initialize the members of the structure, you can directly do with compile time also. No need of going for runtime. If you want to enter the data through runtime, you can use the scanf function, or else you can directly initialize here the members of the structure. So suppose v1 dot s is equals to, like that you can initialize v2 dot v1 dot s is equals to, like that you can initialize your members. You can use initialize at runtime. Next one is the self-referential structures. We will see what is self-referential structures. A structure referring itself is called a self-referential structures. That means if one or more pointers pointing to the structure of same type are called the self-referential structures. if one or more pointers pointing to the structure of same type are called self-referential structures. So this is the syntax of self-referential structures. Struct structure name pointer. So the members of the structure here was declared. Okay, and the example, if you take struct node, this is the name of the structure. And that name consists of, the members are data, and this is a pointer. So this pointer is pointing to the structure of same type. Here a link is a member, but that is pointing to the structure of same type struct node. So this is self-referential structures. So let's see one more example. Struct code. Okay, so this is one more structure I have declared here. What is the name of the structure? Code is the name of the structure. Int. So these are the members of the structure. Okay, so one data type of integer, another one is character. But here this is a pointer variable which is pointing to the structure of same type. So normally what a pointer holds? Pointer holds the address of another data type, right? So here, this pointer p is a structure member, but it is pointing to the structure of same type. So that pointers are called, that type of structures are called the self-referential structures. If one or more pointers pointing to the structure of same type are called the self-referential structures. Let's see with an example. Again, we will declare the structure. Struct code int r char c struct code pointer. So this is your structure declaration. Next, in the main function, so just let's declare one variable, struct code s or s1. So I have declared one variable s1. So now how you can access the members of this members by using s1? It is s1.r and s1.c. So suppose if I initialize like this, s1.r, it's an integer number 10. Next s1.c, it's a character. So obviously character is, will take a character variable. Okay. Next s1.p, it is pointing to itself, so it will be obviously a null. Suppose if I specify like this, the representation, it's s1 structure 1 and it contains s1.r is 10 and a character, and this is a null. Suppose I have written again like this, struct code s2, one more structure variable I have declared. And if I again initialize like this, s2 dot r is equals to 20, s2 dot c is equals to p, and s2 dot p is equals to null. Obviously, right? It is again a variable. This variable, with the help of variable, we are trying to access the members of the structure. The members of the structures are r, c, and this is a pointer variable which is pointing to the same type. So it's a self-referential structure. So s2 dot p is equals to null. So what I will do again I'll represent this one. So it is an s2 and it contains 20, p and null. And one thing we'll do, s1 dot p is equals to address of s2. So s1 dot p is equals to address of s2. So what it is, s1 dot p, now it is, suppose this is at the 1000 location and this is at the 2000 location, the second one. Okay, so now it knows the address of this s2, the next structure. So this address will be copied here. Okay, so this is what you can access the data from s1 to s2. Suppose if I write like this, what will be the answer I'll get? S1 dot R is 10 and S1 dot C is B. So by knowing the address, you can access the members of the another structure. So with the help of pointers. So what's this self-referential structures? One or more pointers pointing to the structure of same type are called the self-referential structures.